Today we discuss about concept of time, distance and shielding. Introduction. Any work involving ionization radiation may entail some potential hazard. Based on ICRP system of dose limitation, it is essential that the dose are kept as low as reasonable and achievable, called as ALARA, ALARA. A knowledge of the nature and the degree of potential hazard will be help to take appropriate control measures. In telegamma unit, in the on position, the source is adequately shielded except for primary beam. In case of X-ray machine, radiation is emitted during the time when unit is ionized or when X-ray is on or when X-ray is exposed. Radiation hazard is mainly classified into two categories. One is internal hazard and second is external hazard. Internal hazard. Internal hazard arise due to actual entry of radioactive material into the living organism. The main route of in- integer inhalation of combined air, ingestion of contaminated food and water, entry of radionuclide directly into the bloodstream through open wound. External hazard. External hazard is caused when the source of radiation is out the body. Example, X-ray and selected radioactive source. From external point of view, X-ray, gamma ray are most hazardous on accounts of their higher penetrating power, beta ray next, and lastly the alpha particles. Hazard evolution is necessary in order to take control measure in radiation area. The evolution of radiation hazard start at the design stage of radiation equipment. Under the present regulation, it is the duty of manufacturer to ensure that the equipment meet the stupidity radiation safety standard. Similarly, the user of radiation source is required to ensure safety for patients, personnel and public. It is essential to evaluate the hazard like to arise under normal working condition as also under potential accident condition, example fire and explosion of radionuclides. Time shielding and distance, which is also called as time, distance and shielding. The basic fundamental factor by which external exposure to radiation can be controlled are time, distance and shielding. Time. For a given shielding and distance of source, the exposure from a source at a point will be directly proportional to the time during which the exposure is on. Lesser the time of operation, lesser will be the radiation dose. The exposure rate from a telecobalt source is 200 R per minute at 1 meter. What is the exposure in 15 seconds, 3 seconds and 1 hour? First we see the 15 second. So we convert the 15 second into minutes, which is 0.25 minutes. Then we put the formula exposure is equal to exposure rate into time is equal to 200 rad into 0.25 is equal to 50 R. Then time for 3 minutes, we put the formula and we find the answer 600 R, which is the final answer. And for 1 hour, we find 12,000 rad per hour. hour. The exposure increase linearity with time, doub- double the time, double the dose. Time. The then we discuss about time. The exposure rate from this is a time example when a engineer is work or service in telecobalt machine. This is the example, wh- which is the source at a point which engineers are doing servicing is 12 milli milliar per hour. Then explore rate is 2 milliar per hour minute. Explore allow per day is 8 mr. Then the engineer is work for 4 minutes for 1 day. Distance. The exposure rate at any point from a source of X-ray or gamma ray varies inversely as the square of distance of point from the source. Inverse square law. Large the distance, lesser will be the radiation dose, with the intensity equivalent to 1 by d2 is equal to I1 by I2 d2 by d1. Then distance. The exposure rate of telecobalt machine is 200 RMM, where the exposure rate of 1 cm, 2 cm, 3 cm, and 4 meter, which is the example of the mathematical questions. Then distance. It is also distance. The exposure rate from the source at a point of 2 meter from the source of 120 mr per hour. However, the long engineer work at a distance of 3 meter and 5 meter without exceeding the dose equivalent limits. Exposure rate is 3 meters. 120 is 40 mr per week, 3 meter, and 5 meter 2 hour 2 minute per week. Shielding. When maximum distance and maximum time does not ensure an acceptably low radiation dose, adequate shielding must be provided so that the radiation beam will be sufficiently attenuated. The exposure rate from the source of X-ray or gamma ray decreases exponentially with thickness of shielding material interposed between the source and the point of interest. If I is the intensity of radiation at a point without shielding and I is the intensity which the thickness of the material is interposed, then I is equal to I0 into E to the power minus lambda t. This is the graph of shielding attenuation. Half value thickness. The thickness of shielding material which reduce the intensity of radiation to half of its original value. It is defined as the half value thickness. half value number of HTV is equal to transmission transmission of radiation is 100%. When STV is 1, transmission of radiation is 50%. When STV is 2, transmission is 25%, and when STV is 10, transmission is 0.1%. 10th value thickness. Thus, shielding material which reduce the intensity to 1/10 of its original value is defined as the 10 value thickness. The relationship between TVT and STV is equal to 1 TVT is equal to 3.3 STV. Then the remember section, time, lower the time of exposure, lower the dose to personal. Hence, other things remaining the same, the exposure time must be keep the minimum possible to ensure minimum dose. Therefore, radiation source must be on for minimum time required. Then, large the distance from the source, lesser the radiation dose. Hence, keep as far away as possible of radiation source. Then shielding, large the shielding thickness, lower exposure rate. Hence, make use of as much shielding as feasible. Then this is the mathematical. The major output of telecobalt machine is 200 rm, while the exposure rate is 1 meter, and the lead thickness is 6 mm, and the interaction between the unit and detector. This is a STV and TVT mathematical calculation. 6 cm of PB is equal to 5 STVS. The exposure rate 200 by 2 to the power 5 is equal to 200 by 32 is equal to 6.5 R per minute. Then the exposure rate of CS137 source is a point of 120 mr per hour. How much light should be interspersed between the source and the point so that the exposure level should be brought down to 0.25 mr per hour at the place STB is equal to PB is equal to 0.6 cm. Thank you for watching this video. This video is referred from Radiotherapy Technologists safety course book and online source of ARB websites.